Hi, everyone. Let's go ahead and get started. So welcome. Thanks for coming to my presentation. My name is Dale Kim. I'm the Director of Industry Solutions at MapR Technologies. And if you look at your program schedule, you'll probably see that there's a different name. My colleague, Tomer Sharon, couldn't make it, and unfortunately, we couldn't make the name change in the programs in time for the Hadoop Summit. So apologies for the change, but I hope I do justice to this presentation. So again, thank you for coming. So I'm here to talk about delivering on the Hadoop HBase integrated architecture. So just to be clear, everyone knows what Hadoop is, right? Because I didn't create any slides about that. So are we good? We're good? OK. So we're going to talk about HBase and Hadoop. So talk about that integrated architecture more than just how it's running together, but what are some additional capabilities you get? What are some of the additional use cases that you might derive? Some of the challenges, some of the pitfalls that you might face, and if running HBase together with Hadoop in a multi-workload environment were such an easy thing, then everyone would be doing it. There are a lot of capabilities that you could get, but there are some challenges. So I want to talk a little bit about that, and then talk a little bit about the future of such an integrated architecture, where I want to see the industry going, where it looks like it's going to go, and take it from there. So most of you probably know that MapR Technologies is a distributor for Hadoop. We're based in San Jose, so almost right around the corner from here. And we were recently written up as one of the top distributions for Apache Hadoop, so that's one of the things I'm particularly proud of. But most of this discussion will be more about Hadoop and HBase in general. So even though this is a paid presentation where I paid good money to be up here, I'll try to keep it as vendor neutral as possible. So I'll be talking about HBase and the integration with Hadoop, and we like the term In-Hadoop database, which is simply that. A database that's running within the context of Hadoop, mostly about working with HDFS or the file system level so that you can take advantage of the distributed nature of that file system and all the goodness that you get with it. So I'll talk a little bit about that, talk a little bit about some in-Hadoop databases in action, what are some big customers and Web 2.0 customers that are using this integrated architecture and some of the benefits they get out of it and what they deliver for their customers. And then I want to talk about architectures at a few different dimensions. Some at the node level, so how the different technologies, the software technologies, interact with the file system within a node, as well as talk about some of the higher level architectures and how, as you, an enterprise architect, might want to design a system leveraging Hadoop and HBase. Then I wanted to talk a bit about some of the best practices associated with getting started when you want to build such an integrated architecture. But it seems like there's no one set of rules, no silver bullet for getting started. So I want to give you some reminders about taking baby steps if you haven't already implemented such an environment, and just remind you of the things that you need to watch out for. And then talk about what's next in the future, some of the innovations in HBase, some of the innovations in the industry, and what are some of the technologies that you can think about using. So if you ask, what would Google do? Or maybe now you would ask, what did Google do? Remember a time when their bread and butter was search technology. I mean, they get into Android phones now, into self-driving cars, Google Glass, and all kinds of crazy stuff. But there was a time when they were strictly a search engine. And the way they handled searching and indexing and searching data across the World Wide Web was adopting this relatively new model of using commodity hardware to scale out. And most of you will be familiar with this notion of using Hadoop as creating that scale-out architecture. Well, they had the technology MapReduce, as you all know, the Google file system. And so they had this great system for distributing work across many nodes, doing some batch indexing. And so you might put together a new website, and then 2 weeks later, lo and behold, it was searchable on Google. And you thought that was fantastic. And of course, they've made a lot of advances since then. But now, a lot of that technology still applies. But at the time, it was great that in a 2-week span, this batch job could get your files indexed. And of course, the Google file system had some specific characteristics that made it optimized for this environment of indexing a lot of web content. And that's some of those characteristics are carried over into Hadoop today. So I'll get more into that. So there was this transition from this notion of batch indexing, where you want to do things at large scale, and whatever returned, whenever it was done, that was good enough. And that worked. But there was this notion about user interactivity. What can users do in interacting with Google where they can get real-time responsiveness, they can add some additional data, make some changes, essentially look like a database application. And that's why they came up with Bigtable. And in fact, our founder MC Srivas, who used to work at Google, headed up the big table team. So he was responsible for a lot of the technologies that added this operational aspect to the Google platform. So when you think about the two types of workloads, one is the batch that we talked about. You can kind of extend batch to be analytical. So if you're analyzing data, then that's a common use case for Hadoop, as you all know. And the other side is operational. So when you put those two together, you have the notion of operational analytics. And there are a number of ways that you can describe that. So some people refer to it as operational analytics. Some people refer to it as HTAP. I think that's an industry term, industry analyst term for high-performance transaction, application processing, analytical processing. So there's going to be a number of terms, I think, that will emerge to talk about this integrated architecture where you're doing analytics and operational work in the same environment. So when you think about the separation of the two types of workloads, it's often due to the fact that data is used in different ways. So if you look at the two types of technologies that handle the data, you look at operational data and analytical data, you generally think of databases and data warehouses. So if you think of these as different beasts, the operational data tends to be real-time, very interactive. Analytics is more about batch. Send off a job, a week later you get some results, and those are very good results, and that works for you. Operations also deal with immediate read-writes and updates, whereas analytics are more about reporting. Operations are also about recent data, whereas analytics generally extends to longer tail data, historical data, this broad range of data that results in this big volume that you want to run the batch analytics on. Operations are updated regularly. Analytics, like in Hadoop, are generally non-volatile. And as you know, the HDFS platform supports that, where it's expecting a lot of data that you're generally not going to update a lot. Fast inserts, updates, fast retrievals on the analytics side. And of course, with this notion of big data, you see a lot of NoSQL databases, you see a lot of big data warehouses, you see a lot of SQL-based or relational databases dealing with large volumes of data. And I still get the question of what's that threshold for what big data is? And I always have to cop out and say there is no real number, and I always get a dissatisfied look in their faces. But that is the fact. There is no firm number. It's more about how much trouble do you face with the amount of volume that you currently have. So I copped out on this response with the volume of data for databases by simply saying large versus even larger volumes. And that's probably reflective of the type of environments you have. So I talked about these two different beasts, two different types of data on the database side and on the data warehouse side. But you have to ask, is the data really different? Now, if you're a database guy, you probably say, yes, it's very much different, because after all, you create the data that you store oftentimes. If you're running a MySQL, an Oracle, maybe a lot of these NoSQL databases, you're creating that data. You might schlep it off somewhere else, and you don't know what happens, but some analytical guy deals with it, or you do some analytical processing within the context of that database. And so you think of that as one set of data, and there's other sets of data you don't worry about. But of course, if you're an analytics person, you know that your data comes from somewhere else. So you see that even if the data is operational from some operational source, it'll come to you, and you'll do some processing on that. So why is that important? That means that ultimately all this information is the same, and you want to do analytics on your real-time, interactive, end user-based data. But there's an acceptance that with technologies today, you typically create two separate clusters. One for your real-time interactive data here. So you might have application servers that collect data from end user interactions. And then you have larger scale analytics done in batch that collect large volumes of data. You run all kinds of processing over them. Getting that large volume of data allows you to make more calculations, analyze it at a very granular level, and come up with some analysis based on the aggregate of all the information you've collected. So if you think about, for example, churn analysis, you don't want to look at individuals. You want to look at the aggregate and see what are the patterns that represent somebody who's going to leave you as a customer. Now, unfortunately, for that model to be valid, you actually have to have customers leaving you. But when you get enough of those that happen, you can collect it all together and find that pattern that perhaps will help you prevent such a departure. In a Customer 360 dashboard, has a lot to do with consolidating data from across many different silos. So if you have different repositories of data that represent different views into your customers, you can consolidate it into one and get that complete view so they have better opportunities for doing things like recommendations or maybe even fraud analysis related to anomaly detection of the transactions. And then data exploration simply deals with getting a large volume of data and just exploring it, going through discovery to see are there any additional insights that you can gather from looking at products, from sales, from customers, and so on. So if you want to integrate this information together, typically people expect a batch import and export. Now remember I said that these data types are actually one and the same. Time is probably the big dimension that differ from across these two clusters. And you do a batch import and export. And for a lot of environments, particularly smaller data environments where you have maybe hundreds of gigabytes of data, or maybe less than that, it's probably okay because you're not choking up your bandwidth and not spending a lot of time copying. But if you're looking at an environment where you have more than that, terabytes of data, petabytes of data, you don't want your system choking up the network by copying over the wire back and forth. So you might copy from your operational system over to Hadoop, do some ETL there, perhaps copy it back, do some analytics there, do some more analytics there, and there might be a process where it goes back and forth. And if you do that, you probably think either that you don't have enough data to warrant any additional changes, or that you just accept that that's the architecture, that's what you're stuck with. And some of you probably have very good experiences that suggest, yeah, that's the best way to do it. And so I want to talk about some of the things that are going on in the industry that hopefully will change this model. Now, of course, if I ask this okay, oops, some of you will say this okay. And what I'm trying to say is it will be okay, but it has to be driven from your end users. If your end users say we need more real-time interactivity, we need more real-time responses to analyze the data that's incoming on a continuous basis, then what can we do to change the architecture? So this is the model that I propose with an HBase and Hadoop architecture. HBase being built within Hadoop, you'd think that you can run a single cluster that can store incoming data from the operational side. And at the same time, in situ, you can run these analyses so that in real time you get some insight that you can share with customers, you can deliver to your customers, share with your own employees. And I think the significant thing here is that there are new capabilities that you can add within your cluster that I think might be very critical for creating that competitive advantage in your business. So if you look at something like real-time ad targeting, if you can look in real time at customer behavior or visitor behavior on a particular website, track what they're doing, and based on that immediate action, compare it to the long tail of historical data, make some calculation, and deliver a more optimal ad in that environment, then you might get a slight uptick in clicks to that ad or views of that ad. But anyone in the marketing world or in the e-commerce world will know those small upticks will add up over time. So with incremental technical effort or maybe technical changes to your environment, you could potentially get a lot of value there. There's also the notion of product service optimization and personalization. So again, when changes are being made in real time, you want to be able to capture that and respond right away. And the way to do that is having that single real-time environment that collapses the operational and analytical workloads into one. So if you think about the different types of data that you might have, user profiles, particularly user interactions, any type of real-time location data, and comments and rankings, all of that information will be very useful in an analytical system that you can collect in real time and process and deliver in real time. So just to review, what do you get with this notion of In-Hadoop? Again, there's that real-time analysis and computation. So if you have all that information available immediately, you can respond more quickly. Again, this is an end-user-driven thing or your customer-driven thing. You don't want to build a real-time system just because it's cool. I mean, I tend to do that, but I don't recommend that for you. So if your end users are asking for something to get them to respond more quickly, that's something you might want to look at. Architectural simplicity is always an important thing. You don't have the duplication of data. You also have fewer clusters to manage, and that ultimately results in less opportunity for error, so lower risk of managing fewer clusters, having to deal with duplication of data, and creating more disk space utilization. And of course, the reduced network bandwidth utilization. I mentioned that if you're only dealing with gigabytes of data, then this probably isn't that big of a deal. But if it's taking hours, days to copy data across the wire, then you want to think about an architecture that's going to better support being able to keep data local to where the computation is being done. So let's talk about In-Hadoop databases in action. So a big company based in the Bay Area has huge campus, many buildings, is Cisco. I'm sure all of you have heard of them. Cisco's so big that they're spread all over San Jose. So if you say something like in the Bay Area that I work near the Oracle buildings, people know where that is. I work near the Yahoo buildings, I know where that is. I work near the Cisco buildings, I don't know what that means. That's how big they are. And I love the fact that they are a MapR customer. But more importantly, to talk about what they're doing in terms of this notion of operations and analytics. They have a couple implementations that will take in live data, and they want to run some calculations on it and be able to deliver some kind of insight. One of them has to do with, surprisingly, or not surprisingly, security. They are a network company, so they do a lot of scanning of their network on their own networks as well as their customer networks, and they want to be able to compare all the historical data to any new incoming data. And as a result, they can do anomaly detection to see anything strange that may be going on that they can further analyze to see if there's a suspicious activity like a security attack. Another environment that they have implemented is essentially what's known as an enterprise data hub. You've also heard of it called a data lake or data reservoir, data swamp, data landfill, depending on how jaded you are. But I call it an enterprise data hub. And that's an environment where you might collect a lot of data, where you do a lot of analytics, and see some insights that could help your business. And one of the things they do, they're very proud about, is that they were able to identify many millions of dollars of incremental revenue for their partner services organization as a result of seeing improperly nurtured customer accounts and seeing some gaps in opportunities for renewals. So putting together just a repository for collecting huge volumes of data allow them to see opportunities for additional revenue. Now, I love the story about Spins because they're essentially a Web 2.0 company, but also a cloud-based marketing analytics company. And they focus on the natural and organic food and products industry. So some of their customers might be retailers like Molly Stone's or Sprouts. Some of their manufacturing companies' customers might be Tom's of Maine or Pop's Chips. And so what they're essentially doing is collecting point-of-sale data from across all their retail customers and create aggregations and reports that they spit out back to their customers so their customers have a better sense of what's going on in the industry around natural and organic products. And as a result, they can make appropriate business decisions in retail around shelf space and allocation. And one of the key things about Spins is that they do a lot of long-tail batch analytics, but they need to deliver that in an online environment. And so when you think about users wanting to read long reports on a website, they expect that low latency, quick response. Not only that, with the type of customers, particularly marketing customers who want to see that response very quickly, if they have to wait a few seconds for a response, they'll probably click refresh again and again and again, adding more load to the server. So you need to make sure that you have that low latency response that you're not going to get from some batch process, but more from a database interactivity type of environment within Hadoop. Exactly as another Web 2.0 cloud-based marketing analytics site, less marketing analytics, more analytics of sales performance compensation. Very similar model where they collect a lot of data, run the analytics, and deliver large-scale reports to their end users. So again, they want to make sure that for their customers who expect immediate delivery of reports, that they have the low latency, the high throughput, they can scale out for their growing customer base and deliver quickly. Just to quickly talk about some of these anonymized customers who gain significant competitive advantage by using Hadoop and some of the related technologies like HBase. Some telecommunication company, particularly one of our customers, will collect a lot of user behavior data from a number of devices as a result of seeing what are interesting to them. And they can make a lot of decisions around advertising, what videos to show. Again, it's about collecting lots of data. It's truly about the volume and variety of big data that they collect. And by collecting it into a real-time streamed system, they can make quick analytics and deliver very much like a real-time ad targeting system. And so this is a composite of a number of financial services customers of MapR that use Hadoop for things like anomaly detection and recommendations. And as strange as those things seem to go together, it's all a result of the type of things that customers do. If you think of the transactions that are captured and then run that against comparisons of historical data, you can see what some of the anomalous behavior might be that might represent fraud. But you can also see some of the patterns around purchases, around interests that might lead to recommendations on what else they may want to purchase or explore. So having this real-time interactive database within the confines of an analytical environment really gives them an opportunity to respond quickly, particularly when customers call in. And they might ask about a particular topic, they might complain about something, and you want to have a response that fits their needs right away. OK, so now let's get to the pictures part. Talk about architectures. So let's talk about architecture at a fairly low level. So if you think about databases on direct attached storage, there are a lot of advantages there in terms of the performance. So it's certainly low cost as well. So if we look at some of the pros, you have the fast local access. If you're running a database, single server, local attached disk, that's pretty straightforward. Certainly lower cost because it's considered commodity disks versus a more expensive SAN. But certainly there are a number of disadvantages. There's no storage management. Each node is run independently without any particular storage management for your collection of disks. Potentially wasted capacity, because the disks aren't shared across your entire cluster. They're dedicated to each of your servers. No snapshots, unreliable storage. And then to scale to capacity, you have to add more nodes with X number of disks attached. So certainly, this is a decent model if you don't really care about losing a node. But when you're talking about enterprise deployments, this may not be the right solution for you. So this is something that a lot of corporations and enterprises have adopted, the notion of using some type of network attached storage, whether a SAN or a NAS. So you'll have a number of nodes each running a database server, all connected over the wire to some big cloud-like repository. And you get a lot of benefits by expending the money for such an environment. You have snapshots, backups, the easy capacity expansion, very enterprise-grade, very enterprise-grade requirements like disaster recovery, disk utilization, the whole reliability maintenance, like all the goodness that you would expect in an enterprise-grade environment or an enterprise-ready environment you can get from SANs. Of course, because you're reading data over the network, there's some latency associated there. Certainly, it's expensive. And there's one interesting point that I found fascinating that I would never thought of before. If you're running a complex and expensive set of database servers over the SAN, sometimes you don't think about what your corporate policies are around provisioning from a SAN. So I had been told about a customer who had under-provisioned their SAN for their database cluster. And as a result, sometimes the system thought that the network was down or that the disks were down. And when a cluster that's designed to be highly available thinks that a part of it's down, then you can create a lot of havoc that way. And that's a result of adhering to corporate standards without preparing ahead of time that you need a lot of provisioning power. So let's come to databases on Hadoop, the notion of In-Hadoop. So because HDFS is a distributed file system that can be essentially shared disks across a network and appear as if it's one big cloud-based disk, it works pretty well for database servers on commodity hardware. So you get a lot of the things that you would expect in an enterprise deployment. The high availability, local file access, dynamic storage utilization. So you get a lot of goodness there. And that's the reason why a lot of companies are moving in that direction in trying to deploy databases on Hadoop and specifically HDFS. Some of the cons, there are very vendor-specific cons that you can look at the various distributions. So let's just leave it at that for now. If you wanted to hear more about what MapR can provide, we have a booth here at Hadoop Summit. Feel free to stop by, and we'd be happy to talk to you, hear about what some of your challenges are and how we can help you there. OK, so jumping a little bit ahead, if you look at some of the pieces for Hadoop, if you're talking about an environment where, hold on just a second. OK. Some of the pieces of the environment that you set up that will include operational and analytical workloads. There are a number of SQL query engines. Some of the popular ones include Hive, Impala, Presto, and Shark, and of course, for full disclosure purposes, Apache Drill, which is a MapR-initiated project. It is an Apache project, but it was initiated by MapR. And then there are a number of streaming technologies like Kafka, Flume, Scribe, even some commercial options as well from like Informatica, their data vibe stream option for pulling in high-speed data. So I wanted to give a matrix that kind of talked about the different characteristics of each of these technologies, but I found out that there was going to be a non-winning situation. And every time I show it to somebody will always have some criticism about what's being focused, what's not being focused. So let's just leave it as this slide being the NASCAR slide of sorts of the different technologies that are possible, and I just recommend that you do some research as to what fits well for you. And it's typically going to be someone in your organization that says, I have experience with that, let's go with that. Give it a try and see how it works. OK, I think I lost a slide here. Is there any reason this is dark? OK. Unfortunately, that was my best slide. OK, so I do want to talk about that slide, because it actually was my best slide. I was going to talk about the Lambda architecture. So actually ignore this. Let's go back to the blank slide. So you're going to have to use a little bit of creativity here. I apologize for the slide. So if some of you are aware of the Lambda architecture, that's an architectural design created by a man named Nathan Mars, who was originally a Backtype, which was acquired by Twitter. And he designed that architecture to handle high-speed streams of incoming data. And when you think of what Backtype did, they did analytics on high-speed incoming data. You think that such an environment makes sense. And if you look at the Lambda architecture, there's no requirement around the type of technologies that you use or the specific topology of the environment. But there is some implication of Hadoop, maybe strong implication of Hadoop. And there is some design built in that the environment can't handle high-speed streams right off the bat. So if I did have the slide, there would have been a box here that talks about the incoming stream. So in the Lambda architecture, the incoming stream is split off into two. So there's going to be a speed layer and a batch layer. And so that information is sped up into two to kind of accommodate some of the limitations of the technologies they were using. So imagine that box there, and it goes up here. And there would be a batch layer here. And that's where all the data will eventually reside. So that's the batch layer, meaning that it's the final resting place for all the data. And what you do there is run something like MapReduce to create some batch views. So you're computing some views for use for querying. I really apologize for this. And then at the bottom end, you'd see the speed layer. And that's where, yeah. Oh, I don't. Yeah, you guys can't see this, can you? Yeah. So, there it is. There we go. OK, so here was where the data is coming in. It was split off. Here's the batch layer. So this is where you store information in something like HDFS. You run MapReduce to compute it into perhaps flat files and then run Hive on it so that you can do some querying for all the quote-unquote historical data. So this is the repository for everything that you have. So if you do that, when you run MapReduce, it is a batch layer. So there will be some delay before you get to see the most recent data. And Nathan was saying that that's not acceptable. You need to be able to access real-time data immediately. And that's why there's the speed layer, where you might use a technology like Storm loading into HBase. And that would be immediately available. And what happens here is that as your batch layer continues to grow incrementally in chunks as a result of the batch compute of the new views, you have the incoming data loaded on the speed layer so that you have a time window of the most recent data continually moving so that when you have the merged view, you can do a query over all the batch data and over the speed layer simultaneously. And so when you think about it, why do you have to break it up? Because there is this belief that this is not going to keep up, and you need to have access to real-time data at the bottom. And then with the merged data, you can search over both. Question? I'm sorry. There's going to be a little bit. Yeah. So what this is trying to do is trying to minimize that. Yeah, absolutely. Can we go next? So of course, that was Lambda architecture. You can read more about it from lambda-architecture.net. All right. So this is the Enterprise Data Hub architecture. And I thought the Lambda architecture was a cool name, so I proposed to my boss that we call this the Oopsilon architecture. And I said that wouldn't it be cool if we could call it the Oopsie architecture for short? But apparently I lost him there. But anyway, so we call this the Enterprise Database architecture, Enterprise Data Hub architecture. You'll see this from a lot of Hadoop vendors. This is the central repository for data from a number of data sources, particularly data warehouses. So if you look at the data sources here, you may load, do a bunch of data integration type of things, as well as high-speed streaming. Load it into the central repository, and here I have MapR depicted, but it could be pretty much any Hadoop distribution. You could do some enrichment with tools there, and then you load it into your data warehouse, data marts, for analysis, from either directly from Hadoop or from the data warehouse. So this isn't necessarily mutually exclusive from the Lambda architecture. In fact, the Lambda architecture will be a component of this, particularly at a high-speed streaming level. And so where this becomes useful in terms of loading real-time data and running operational analytics is on this end, where you might store a lot of information in some kind of low-latency, real-time technology, and then have all the results searched up here. So this is just another way that you can think about deploying an integrated architecture with both operational and analytical workloads within the context of an enterprise data hub. So some of the use cases of enterprise data hub, like I talked about, is consolidating data silos from a number of sources. Also, there's this notion of data warehouse optimization, where you might have a big, expensive, but very useful and very valuable data warehouse that's busting at the seams with all its data. And rather than buying a brand new set of machines and licenses, you want to offload some of the less frequently used and maybe the less quote-unquote valuable data onto Hadoop. Do some batch analytics there, but keep all the high value and recent data in your data warehouse. So let me talk a little bit about getting started. So I mentioned earlier that not everybody does this. Not everybody has an integrated cluster, an integrated environment for operational analytics because of some of the challenges you might face in deploying the current technologies around Hadoop. So operational and analytical workloads, as you might know, have different design points. So I think our CTO said something like the operational side expects 20% writes and 80% reads, whereas the analytical side expects vice versa. So if there's that mismatch in terms of reads and writes, then you're going to ask for a lot of contention within an integrated environment. So that's one of the challenges. Some of you might have seen that HBase and MapReduce don't necessarily work together because they want a lot of resources. They fight each other for a lot of resources. Certainly Yarn will help. Yarn will help go a long way, but there are some environments where you might have very stringent SLAs and you won't have guaranteed capacity, and Yarn won't necessarily help you there. So you might have a lot of batch analytical processes running, a lot of real-time processes running, but Yarn won't be able to make sure that your responsiveness still is within your guaranteed SLAs. And then there's the notion of HBase compactions. Now, I think HBase is an outstanding technology, and sometimes when talking about it, I feel like I'm disparaging it, when in fact, there's actually some challenges around some of the design considerations of HDFS, mostly the fact that it is a write once, read many architecture. And having a database system that can essentially run random read and writes on top of it, I think is an outstanding feat. Yet, there are some architectural challenges that come out as a result, particularly the notion of compactions. So you do have to optimize the disks afterwards and clean it up. So what can we do? Well, I think as a starter to take baby steps, it's about planning ahead. So you want to expect that you're going to learn a lot along the way. So no matter how much you know, no matter how much experience you have with separate clusters of HBase in one and Hadoop in the other, if you try to integrate them, you're going to come across something that you're not going to expect. And so I've seen some environments where customers would be experts in HBase, and so they would come up with different architectural designs to accommodate specific business needs, and then come across a different challenge. Like if you create different clusters, running separate clusters of HBase for the purposes of separating out different data sets, then you add the possibility of system failure as a result of all that redundancy. And that's something that you won't necessarily think is intuitive, but has occurred. And when you do that and you have stringent SLAs, you have a lot of hard conversations you have to make with your customers. So there are many people out there who have successful deployments that you should talk to. I mean, it starts with people in this room, people at meetups, even talking to vendors and getting a sense of what they see from their customers, and of course, validating it with their customers. If you can identify use cases where there are lighter operational loads, so stick to the heavy, very intensive analytical batch processes, but start with something light. Similar to some of the Web 2.0 examples I gave, where there might be some updates and aggregations into HBase, but ultimately the point is about low latency retrievals over a web interface. If you can look for environments and use cases like that, that'll at least get you started, get you familiar with the environment so that you become comfortable with such a deployment. And be sure to look for systems that have plenty of resources available for both the operational and analytical workloads. So don't look for 70% utilization. Look for something more like 25% utilization as a way of getting started. And as you learn and see how your system behaves, knowing that your data is going to grow, your user base is going to grow, just keep in mind that there's always going to be more difficulty down the road than you expect. But ultimately, when you get there, a lot of your end users will come up with business results that'll be very valuable. Let's talk about what's next. Let's talk about some recent HBase innovations. So if some of you aren't that familiar with Hadoop and just know that you came to the Hadoop Summit to learn a little bit more, you probably ask, what's with all these crazy version numbers that are all below 1.0? Because there was a time when version 1.0 of a product meant bleeding edge, and you wanted to avoid it. But you look at something like HBase that's 0.98. That actually represents years of battle-tested work and something that's very solid, and it continues to improve. So HBase 0.98 was released earlier this year, a number of bug fixes, performance improvements, a lot of good stuff happening, and that will continue. One other innovation that's near and dear to my heart for a number of reasons is, as a former C software engineer, the C API for HBase, known as libHBase, is right around the corner. It was created by one of my colleagues at MapR, Aditya, and this is available for download. And in that JIRA that describes this particular requirement, I believe it was Nick from Hortonworks said that a C API is going to be something very critical for a 1.0 product, a 1.0 database. So I think that maybe this libHBase might be that one last hurdle that will get HBase into the 1.0 version. So that's really exciting about where that's going. Let's talk about some other In-Hadoop databases. So I talked about how great it was to have HBase integrated with Hadoop. And if it was a great idea, then certainly other people would be doing it as well. Well, that certainly is the case. So if you look at some of the other technologies, and this is not by any means an exhaustive list, but some of the technologies that you might be familiar with, some of the technologies you might see at a Hadoop Summit. Apache Accumulo about security. Splice Machine is a really fascinating story about relational databases, a full RDBMS running on Hadoop. MarkLogic is for full disclosure, I am a shareholder. But MarkLogic is a deployment, is a database system that runs on Hadoop and takes advantage of the notion of tiered storage. So you can deploy across a number of disks and essentially turn off any disks for any of the low-value archived data. I included Data because they consider themselves a better HBase, but I actually don't know if they run on Hadoop. But I want to include them and have to do some more investigation soon. And of course, MapR M7. So this is a paid presentation, so I hope you give me a little bit of latitude in saying that all the customer use cases that I talked about use MapR M7 and the NoSQL database included in that edition. So again, if you want to learn more about what capabilities we provide, what value we can provide to you, please stop by our booth. And just to wrap up on data warehouses on Hadoop, HP Vertica is a MapR partner, Pivotal Hawk, a data warehouse on Hadoop. Then the Teradata Aster Big Data Analytics appliance is sort of the same thing. I was told it's not really, but I consider it sort of like a data warehouse on Hadoop because they sell you a rack with a number of nodes that try to abstract away the notion of separate nodes, but tie them in close enough together so it appears that they're the same individual cluster. So that's my pitch on the notion of integrated Hadoop and HBase, integrated NoSQL database in Hadoop all together and what you can do with it. I'm almost out of time, but wanted to see if you have any questions. Yes?
How hard or how easy it is to move from a traditional transaction-based databases providing a lot of consistency guarantees to something like Hadoop and HBase, which don't necessarily provide such say asset semantics. It's like just very high and low or more than.
OK, yeah, the question is how hard is it to move from a traditional transaction-based, maybe ACID transaction-based database system into something like Hadoop and Hive? There will be some thinking involved in terms of what type of workload you want to do. So if you're working on a transactional ACID transaction-based system, you probably don't want to mirror that over on Hadoop. You probably want to just copy some of the data for the purposes of analytical processing. Let's take one more question.
Compared about going back to your storage architectures like DAS, directed as and NAS, and you showed the third slide where Hadoop kind of expanded. So it's kind of a network storage emulation or?
Yeah, so the question is, in the third diagram that I showed with databases on storage, the Hadoop story, is that like a expanded SAN? Yeah, it is sort of like that. HDFS will act like a SAN so that you have that distributed nature and then the better utilization of disks. So I think we're out of time. Thanks, everyone, for joining me today. And please visit us at our booth at MapR. Thanks.